Hello and welcome everyone to today's Association for Manufacturing Excellence webinar titled Flow Efficiency versus Resource Efficiency. I'm Jerry Strohmeyer, the Education Training Program Coordinator for AME, and I will be your moderator. Today's presenter is Henric Alsterman, the CEO of Part Development in Sweden. Also joining us is Jim Garrick. Henric Alsterman is a lean management coach and author. Henric has worked with manufacturing and business development since 1983. Both as an employee and with his own company. Through the years, Henric has worked as an operator, process engineer, researcher, and manager. He earned a PhD in engineering with a specialization in flexible production. He has also co-authored 3 books on lean. Jim Garrick is the Operations Excellence Coach at ThyssenKrupp Elevator Corporation. He has over 25 years of experience concentrated in the areas of lean manufacturing and optimization of the enterprise supply chain. Before we start, just a couple of housekeeping items. You will be in listen-only mode throughout the webinar. You will see that you are muted on your attendee panel on the right side of your screen. If you have questions during the webinar, please type them into your question area in the attendee panel and click on Submit. We'll review the questions at the end of today's presentation and answer as many as we can. When you log off today, please check your email inbox. In it will be an invitation and link to fill out a short webinar attendee survey. Please take a few minutes to complete the survey today, as your feedback is very important to us to improve future webinars. Henric has also graciously agreed to provide a PDF of today's presentation. We will be sending that along with a recorded link for a webinar replay to each of you next week. Now, I'm pleased to introduce Henric Alsterman, who will present Flow Efficiency versus Resource Efficiency. Take it away, Henric.
Thank you very much, Jerry-Ann. First, I would like to apologize for that I'm a native speaker, but I try to do my best, okay? So, what is a flow? Within this presentation, a flow is a chain of processes, and the process is a step where value is added. Well, at least value should be added in the step. The outcome of a flow is a product or a service. Sometimes the word process is used for what we here describe as a flow. It is normal to say the assembly process of a car maker, while in this terminology, the assembly of a car consists of a lot of flows, and in every flow there are lots of processes. What we here call a flow is often described as the value stream or a value chain. What we call different things might not be so important as long as we understand what we mean. In many organizations, the focus on improvements over the year has been to streamline the use of each process. Often it's about trying to get any process to work faster and to be used more. The reason is usually that the operations are monitored on how it managed to lower the cost per part in each process. The lower the price in an MRP or ERP system or any other calculating system, the higher the profit should be. It is quite easy to follow up, and it has been natural to follow up for owners and for management. So why do we have flows at all? They are there for creating value for the customer. However, they must be efficient in order to create value for the other stakeholders as well, for example, the owners. In the flows, there are mainly 2 different kinds of efficiency: resource efficiency and flow efficiency. Resource efficiency, that's the sum of all value-adding activities in relation to the highest possible resource utilization. The focus here is to utilize the resources. Flow efficiency, the sum of all value-adding activities in relation to the total lead time for the product or for the service. The focus here is on how the service or product is being refined. This picture shows 2 examples of a water pipe. The upper pipe has different thickness in different locations. This means that every single part of the pipe can let through different amounts of water per seconds or per minute or per whatever. At least if the pieces were not tightly connected to each other. Therefore, the pipe have different capacity in different parts. This can be compared to a flow in an operation, with large resources in some parts and small in others. Even though the flow has very high capacity in some of the parts, the flow as a whole does not deliver more water than the smallest part can let through. The same applies in operation. The process with the lowest capacity sets the limit for what the flow can deliver. The upper pipe's lead time is longer, since that it takes longer time for the water to move from start to finish. It leads to a lower flow efficiency. Meanwhile, a large part of the line will be badly used. The parts being badly used has a low process efficiency. In the lower pipe, the water has a higher flow, and because that it has a higher flow efficiency, the water cannot be stopped somewhere, and thus it runs faster. In addition, the bottom pipe has greater resource efficiency, as every part of it can be used fully. So process efficiency and flow efficiency. What should we strive for? Well, ideally, of course, high resource efficiency and high flow efficiency would be nice. But often, too much focus on high resource efficiency makes the flow efficiency to decrease. Focus tends to be maximum uptime rather than giving the customer what the customer wants. We often see that focus on resource efficiency drives us to overproduce. Quite often in this environment, we make orders too early in order to keep the process working. In this picture, we can see a flow with 3 processes. Process 1, process 2, and process 3. Between process 1 and process 2, there is a buffer. It's 12 pieces in the buffer. They are finished in process 1, but not yet started in process 2. After process 2, there is a buffer with 13 pieces. They are finished in process 2, but not started in process 3. So how long is the lead time? Exactly, it's 28 hours. After 1 hour we're here, after 13 hours we're there, after 14 hours we're here, 27, and then 28 hours. So what kind of rules will that set on the buffers? If we can say that we have 28 hours throughput time or lead time. Well, we have to have some kind of rule on these buffers. Precisely, we need to have the FIFO rule, meaning that the piece that has been here for the longest time is the next piece to go into process 2. If we don't have any rules for the buffers, what can we say about the throughput time? Which will be the shortest throughput time? Well, that would be if we go from process 1 directly to process 2 and then directly to process 3. That makes 3 hours. And what would be the longest process time? Well, we cannot say. If we have the rule FINO, first in, never out, the part will be stuck here forever. So this shows that the more material we have in the flow, the longer the lead time, the lower the flow efficiency. So if we focus very much on keeping this process number 1 up, we will keep running it if process number 2 stops. That will make more pieces in the flow and lower flow efficiency, sorry. So the longer lead time, the more products in the flow. And apart from tying up capital, we don't learn so much on the pull system, making this process in balance with each other. So that's a problem with focusing on process efficiency, because we will not couple the processes together so tightly. So long lead time. Long lead time is a driver for bigger batches by itself, and it creates even longer lead time. If we have a long lead time, the customer will order bigger batches, and if they order bigger batches, we will create even longer lead time, demanding for even bigger batches. So this is a negative spiral. And also, if it takes very long time between the processes, if we have a quality issue, there is a slow quality feedback. So flow efficiency is very good for quality feedback, and low flow efficiency is very bad. We also have something called failure demand. When the customer is not satisfied, we will start to do a lot of other things, searching for material, prioritizing orders, etc. So long lead time gives us a lot of problem. So therefore, we should prioritize to increase the flow efficiency in the first hand, and after that it is possible to fine-tune the resource efficiency. If we put the focus on what the flow should perform to satisfy the customer demand with a minimum of waste, by forming the flow as number one, the flow can put demand on each single process. Therefore, the demand should guide the flow, and the flow should guide the processes. If the flow is set up to the customer demand and the processes are set up to satisfy the demands on the flow, they will not be forced to overproduce to fulfill targets on utilization. So, how can flow efficiency be improved in practice? Well, it's all about decreasing the product's waiting time in the flow. So, short lead time from the starting process to the last process. That calls for the principle continuous flow. So some examples of measures that can be taken is reducing batch sizes, standardized sequence handling, and balancing flows and reduced buffer sizes. So I will here discuss a little bit about balancing flows and reduced buffer sizes. The goal should be to create a flow with little or no differences between the process's true capacity. And of course, all the processes must meet the customer demands. When I say true capacity or real capacity, I mean what the process really can deliver when we consider those daily problems that we cannot avoid. The process in the flow having the lowest real capacity sets the limit for the capacity of the whole flow. This process is often called a bottleneck. We have to make differences between a true bottleneck and a limited resource. So this picture shows a true bottleneck in the top and a limited resource in the bottom. In a true bottleneck, the real capacity is lower than the customer demand. In a limited resource, the capacity is greater or equal than the customer need. Often we believe that the process is a bottleneck because there is a queue in front of it. But that can depend on overproduction from earlier processes. If the capacity differs between processes, it means that we cannot utilize the capacity fully of some of the resources. One challenge is therefore to strive for equal true capacity in all processes within a flow. This is called balancing. To balance a flow means moving resources or moving work content between processes towards a situation where every process in the flow has the same real capacity, and the real capacity should correspond to the customer needs. To be able to balance, we need to know the real capacity of each resource. This might sound obvious, but in many operations there is a lack of reliable time data, so this is a driver for standardized work. This graph shows the work content in time on the y-axis for 15 processes in a flow, and the 15 processes are on the x-axis. Before and after balancing. If we have the same or at least equal workload in the different processes, it will be much easier to create a more continuous flow. The more continuous the flow are, the faster we go from the first process to the last process, which leads us to high flow efficiency. At the same time, when we balance, it's possible to work with the process efficiency in every single process. In order to work with balancing, a visual board is suggested. It will make waste visible. The upper red line here shows the takt time, and the lower shows the desired level of workload. And this is the actual workload. And in some cases, as you can see in the picture, the workload is very low compared to the desired level. So in this picture, the process efficiency is quite low actually. But the good thing is that it's known, the waste is known, and it's even visualized. So this can be part of daily improvement work to work with raising this efficiency, to balance it even more, and for example lowering the takt time. And this type of balancing is preferably made by the employees as part of daily work. So, buffers. According to earlier discussion, buffers affect the flow efficiency and of course even the process efficiency. Buffers are of great importance for the performance of the flow. A buffer's function is to deliver when the process cannot deliver. Buffers are needed partly because of external conditions like customer demand, and partly because of process shortcomings. Within the lean, the goal should be to have as small buffers as possible, since it gives shorter throughput time and it helps to deliver the processes and the pull system. They should, however, not be smaller than the prevailing conditions allow them to be. It is recommended that the delivering process act as the owner for the buffers. Reducing buffer sizes. Every buffer should have a reason to exist, not just because there is some floor space left over where we can put some material. Why is it needed? And where in the flow should it be located? And what minimum size is required? There are different reasons why we need a buffer, and therefore we have different buffer functions. But the different buffer functions, they can be put together in one physical buffer. So large buffers increase the lead time and reduce the flow efficiency. That means that we have to calculate the buffers so they don't get too big. And of course, if the buffer are too small, the system gets too sensitive. So that will destroy both the flow efficiency and the process efficiency. So a disturbance buffer, it compensates for unplanned stops in the delivering processes. To set this buffer, we need to have detailed info about earlier stop patterns. If the stop time is, for example, 1 hour per day, the buffer size will differ. If there is normally 2 stops of half an hour, or if there is normally 60 stops of 1 minute, we will have different buffer sizes depending on. So we really have to take a close look of the problems. There is also a buffer function for planned stops, and as it sounds, it compensates for planned stops. For example, maintenance or installation of new equipment or vacation, it could be. We also have a consumption buffer that compensates for different working hours and between different departments, different batch sizes and variation in demand rate, etc. And a sequence buffer, sometimes we can use a sequence buffer that allows us to change the sequence, so we can create or recreate a desired product range. For example, it's quite good if we have a painting shop and we want to deliver one green, one yellow, one black, one green, one yellow, one black. Maybe it's easier to put them together in the painting shop. So this picture shows buffer patterns and how the buffer sizes varies over time. So in the bottom we have a disturbance buffer which shall protect us for disturbances, and it's often on the same level all the time if nothing changes in the processes. And also if we have a sequence buffer, it's normally in the same quantity all the time. The buffer for planned stops, however, of course, it's not there at all if we don't plan any stop, and we build it up before the stop, and then we consume from the buffer during the stop, and it will be down at 0 after the planned stop. The consumption buffer is similar, it varies over time, but the variations are normally much smaller than for a planned stop. Consumption buffer is needed typically if we work, for example, 2 shifts in one department and 3 shifts in the next department. So when the 2 shifts leave for the day, there must be at least 8 hours of workload so that the 3rd shift can work the whole night. Next section, keeping the efficiency up. How do we generate results? The values in an organization can be expressed as the soul, and it sets the rules for how we shall behave to each other. The principles, in this case the lean principles, guides us how to think. Unfortunately, just thinking does not generate any results at all in most of the times, so we have to do something as well. Within lean, we are convinced that the use of proper methods will give the right results, so a lot of effort is put on method and ways of working. If we are not satisfied with the result, we step back up to the methods. If they are used correctly, we evaluate if the methods are truly based on our principles. So in this context, both process efficiency and flow efficiency is a result which depends on the way we work. In order to keep the efficiency high, we need a system to work with deviation from expected levels. I will now present a way of working that can deal with any types of deviations on a daily basis. So first, what is a deviation? A deviation is a result or event that deviates from a standard. You can also say that it's a concrete form of waste, which could be related, for example, to time, cost, quality, something else. Deviations are where daily Kaizen should be focused on. But as I said, to be able to detect deviation, we need a standard to tell what's right from wrong. If we don't have standardized, for example, what time at the morning we shall come to work. We cannot say that someone is being late. So standards are the foundation for daily Kaizen. That's one of the reasons where standard is also being considered as a basic condition in Lean. So the relation between standard and a deviation. There are two questions that we should always ask. Both of them are related to standard. If we have a problem or a deviation, the first question is, does a standard exist? That's a simple yes or no answer. If the standard doesn't exist and we think that we have a problem or a deviation, the simple answer is that we have to make a standard in order to make sure that this problem or deviation will not reoccur. If the standard exists, it's a yes in this box. Then the next question is, did we use the standard? If we didn't use the standard, the answer is train. Then we have to train the staff why it's important to use the standard. And if the standard is used and still we think that we have a problem or a deviation, then we have to work with the standard. Then we have to change the standard or ways of working in order so that the problem or deviation will not reoccur. Sorry. And to be effective, this question should be aimed at the ways of working and not to the personnel who caused the deviation. With this assumption that if we think that everyone do his or her best at work, if we truly believe in that, it's not effective to ask people to stop making mistakes. If I make a mistake when I try to do my best, I will probably do the same mistake again. So we have to improve the conditions. We have to make it easier to do right if we really want to improve. So questioning ways of working instead of people, then we can, if we do that, then we don't blame and have a new blame culture. People would like to show deviations and not to hide them. So you will get what you ask for. So if we show people that they made a mistake, they will hide them. And if we encourage them that it's good to find deviation, they will find deviations. So we have to understand that it's about to change the conditions to do things right. So that is actually a success factor to really question ways of working and not people. So in this section we will discuss a system, how we can work with this daily Kaizen from deviations. So there are different kinds of improvement work. There are larger projects. This typically involves experts and maybe some selected employees. There are smaller projects, maybe some weeks, often called Kaizen events. Both of them are of course important in order to improve. However, to involve everybody every day calls for quite easy tasks to improve. So we have to find something very easy so we can use every day. So therefore the deviation is a very good fuel to work with this. Even though we want to take care of the deviation, we want to work with good ideas in the same system. And also we want to take care of challenges from leaders. So example of a challenges from leaders could be to lower the takt time at the station. To really challenge that if we have 10 minutes takt time in a station, the leader said, now we try one day with 9 minutes, and then we see what happens. Then we will see a lot of new ways that we might take care of. So also this, in the same system, we want to take care of good ideas, but just good ideas it's not so good to base a Kaizen system on, because we will lack for them after a while. But a deviation, they will never occur. It depends on the resolution we look at our operations. So in many operations or organizations, deviations are equal to quality problems, and most organizations deals with them. These kinds of deviation, they are often known. Deviation in time when performing a task are normally only visible in tacted environment, or if the time deviation is very large. Of course, if we miss one project with 1 week or something like that, everybody knows it. But if we work with a task that should take 2 hours and it takes 3 hours, we normally don't bother actually. So in a tacted environment, if we have for example, I have 60 seconds to perform a task and it takes 62 seconds. If it's strictly tacted, we will see the deviation. It might be a missing tool or something like that. So we can find very small deviations if we look sharp at the time. So, but most people don't work in that kind of environments. So look at this picture. If you, for example, plan to do 4 different tasks during the day, every task should take 2 hours, and the outcome is like this: one take 1.5 hour, 1 hour, 3 hour, and 2.5 hour. We can look at our operations, and we can when we go home we can say, yes, I finished everything I should do. That's great. Or we can say, oh, I didn't manage to plan anything. I'm useless. Or we can see, is there anything here to learn? So next time I plan the C, maybe 3 hours is the right time. It might not be any problem. Then I have to know, because if I want to do 4 C during one day, I have to bring in more stuff. So by looking at time, we can find a lot of deviations to work with in our improvement team. So for example, if the D is that we were missing some information, then we can really put focus on, we need to have all the information before we start these tasks. When we see a problem, there are often different time scale for solving and fixing the problems. Relating to the earlier example of a very short tack time, if, for example, if we miss one tool at this, when we have a tack time of 60 seconds, moving the toolboard might not be the right solution, or buying a new toolboard. The short-term solution is probably to get the damn screw there and then to continue with the next product. But the long-term solution is something else. So the short-term solution is important in order to keep the pace. But the long-term solution is very important in order that the problem should not reoccur. So this example can of course be scaled up from seconds to minutes to hours or days or whatever. So it's very important to work with both these kinds of things. Very fast fixing the problem, but the most important is to solve it so it does not occur again. So the improvement team. If we work with daily Kaizen, in order to succeed, we must work in teams. And one team is typically responsible for one improvement area, which might be a process, a flow, part of a flow, or just a physical area. The team prioritize and follow up together, but a single task with finding a solution for a specific deviation is done by an individual, and an individual is responsible for that task. And it's no problem if that responsible the responsible person needs help, but still it's one responsible. So the team-based approach is also very good for getting accept within the group. So no player is better than the whole team is valid even here. So this is a picture of an improvement board. So this is what we can say is the hub in the improvement work. It's typically just a whiteboard, and it's located close to the members of the group. And the board should visualize decision made and visualize ongoing activities and the status of that. And it's the same time, the board is the meeting point for the improvement team meeting. Improvement board can look at in many ways. There is not one answer, but we strongly recommend that at least these points are on the board. We have the ongoing activities. This is actually where the tasks we are working with right now. Who is responsible, and when it should be finished. And also we have a PDA sign here, so we can see which status this task is in right now. And this is also a driver to put some pressure that PDCA is very important to use all the time. The gross list, this is actually where we just put the deviation that we find. We put them in a noted block. Pending is those deviations that we cannot handle by ourselves in this team, so we send them somewhere else. I will explain a little bit later. Accomplished improvements is the list of what we have succeeded with, and we also have a guarantee list with the ongoing activities, but they have to be evaluated for a long time. Then we take them from here and put them in guarantee, so we can make space for more improvement. And this is strongly recommended that it's like one line for every member in the team. So no one should work with more improvements than one at a time. And these meetings are typically held once a week or something like that, but sometimes they can be more often if needed. So this is a scheme that describes the workflow within this kinds of system. From we discover a deviation, that's where it starts. So if possible, when we discover the deviation, of course, if we can really gather the facts as possible, so as much facts as possible when it just has happened, of course it's very good. But sometimes we have to find this short-time solution, and then it's important to gather facts so we can analyze it at the later stage. So we gather facts, and then we note the deviation, and we just put it here on the gross list, and nothing will happen until we have the next meeting. During the meeting, we often start with following up what's happened since next time, so we can take down improve activities from the activity list. And the aim of meeting, except following up, is to prioritize the new deviation and to find who is going to be responsible for which deviation. So in this example, we use a pick chart. It was originally developed by Lockheed Martin, and it's used for prioritization. So on the axis, we have large or small effect, and small effort and large effort. And effect is actually what kind of effect will we have if we solve this problem or solve with this deviation, and how much effort do we have to put in to solve it. So by simply moving the post-it from the gross list to this pick chart, we put them in different locations here, and this is a kind of filter for taking away things we shouldn't work with, and it also gives a chance for everybody to say yes or no, and this has larger effect, or this is very difficult to do, or it's easy to do. So it's not easy to prioritize it 100% right, but still it's a very very good model to do it quickly. And the green line here shows in which order to pick. Of course, we want to have large effect with small effort. And this is one way to prioritize. And another way, that thing that can be discussed, is when we start with new kind of improvement system, quite often we see this as a kind of magic tool, and then now we involve our stuff, and then we might be able to solve all these problems that we have struggled with for a long time. So that is a little bit warning for that. This system is very good for taking care of small deviations. Of course, bigger things can be handled as well, but it's very good if we can solve small tasks often. So winning small victories often is a key to success in this area. So therefore, it's good to take a lot of things that are easy to solve in order to train in improvement work before we take the big fishes. So when we decide who is going to do which kind of task, we put it on the ongoing activities. And if we try to have an activity that should be finished the next meeting. So if the task is too big, we break them down into smaller pieces. So for example, the task for next week can be just to plan the improvement. And after planning, we can split it up to how many activities that we need to. So the goal is that for the next meeting, we should have accomplished what's written here on the line, so we move forward all the time. So next step is to analyze the deviation, and this we do on our own or with someone else, but we don't do it in this improvement meeting. And one popular method is the 5 why. So asking why at least 5 times, it sounds very simple, but in reality it gets a little bit tougher every time to raise the question. The first question are quite simple, of course, but it gets worse and worse, and I cannot say that I truly believe that it always shall be 5 questions. Sometimes 4 might be enough, or we have to ask 7. It's a little bit tricky to just say 5 questions, and what we are looking for is, of course, the root cause. And one of the major problems with using the 5 why method is that we try to use it on several different deviations at the same time. So we have a group of problem and we try to use 5 why, but it's actually, in my opinion, only work if we look at a single deviation. Because if we have a lot of problems, then it might be different deviations. So if we have a group of problem, we can use a fishbone or Ishikawa or something like that. So next step is to decide if we can solve the problem within our own team or if we have to transfer it. If we keep it within the groups, we have to plan the implementation, and this step is we shall not underestimate. If we plan it, planning is everything, then it's quite simple to do the rest, I would say. So if we plan it and we solve it, we conduct the planned activities, the next step is to gain support, and this is also very good with this team-based approach, because before we implement, we discuss with the other team members, do you agree, what do you think? And even though sometimes everybody's saying that sounds very, very good. We have to test the ways of working because we cannot be sure that we really secure the problem or that we have found a new way. So test ways of working is always important to make evidence for the improvement. If we cannot do it by themselves, by ourselves, we have to transfer the deviation. And it is suggested that everybody in an organization belongs to an improvement group. So we can send them to the specialist or the R&D or whatever. If we transfer a deviation, it will be on their gross list, and we will note it as pending. And of course, if it goes to their gross list, it has to pass the pick chart, so it might be possible that they don't prioritize it. So if we think it's very important, then we can go to the meeting and we can say you have to work with our deviation. But this system is not exact, so sometimes it might be killed in another department. And if the deviations reoccur, probably they would realize they will put a little bit bigger effort next time they prioritize. So if it reoccurs many times, it will probably not be killed. But the important thing here is to solve a lot of problems, and some of them might not pass the system the first time. So sometimes we have to evaluate, and the evaluation can take some time, and therefore we want to take it away from our activity list and put it in quarantine. So we have a special list for this, so we don't forget them. And sometimes maybe we have to stress test something, or we have to wait for 6 months to say, or even 3 weeks. We want to have this quarantine list because we want so much focus on that it happens things on the activity lists or between every meeting. So we want to take them away if they so they don't block positions on the activity list. And if we passing this directly or not, but we agree that we have made an improvement. The act phase on PDCA is to update the standard, to spread the standard. And spreading the standard can mean that we inform everybody all shifts, or it can also include that we give information to different departments that have similar work content or something like that, and then we close it and add it to accomplished improvements. So this is just a list where we write down what we have done. And we can also log if we killed or didn't succeed or anything like that. And it's quite good to have in this system, because when we look for more deviations, we see so many problems, so we really don't realize how many problems we have solved, because we see new problems all the time. So it can be quite nice to see these kinds of lists. And one important thing when we work with this kind of system is that everyone is involved. So all the employees have two equally important tasks, and it's to perform the assigned work and to improve their ways of working. And in order to make that happen, it's important how the leaders act. I mean, it should not be an option to participate. But on the other hand, we must have quite realistic expectations. I mean, not all the people run to work in order to improve. A lot of people go to work to get their salary and run home to spend time with their family. So therefore, it's very important how the leaders work with this. So therefore, the leaders have two equally important tasks, and it's to develop the skills of their employees and also to develop their own ways of working in leadership, for example. And this demands, among other things, that the leaders has to have time to lead. It's quite often a problem that the leaders work with a lot of other things than leading their workforce. So I think organizations that really succeed with lean, the leaders spend time leading and not quite much, not just working and having the leading role because they are good at working. It's also important that all organizational levels are involved. When we work with the improvement, it's important that the people working with improvement have some resources to discuss with, to get help from. So they must be supported by the rest of the organization. And here, rapid feedback is very important for the commitment. If we want to develop something until the next week, we cannot wait 14 days for an answer. So the feedback is important. To help in guidance for the employees and also to clarify what is expected from each one, there are 4 employee principles. These principles represent ways of thinking that guides. And they are: act in line with the values, follow standards, cooperate, and participate in the improvement work. Act in line with the values means that everyone lives in accordance with the common shared values. Follow standards. This can mean, for example, carrying out tasks in an agreed upon way, or storing things where they should be, or just follow standards in general. And the principle incorporates themes from the conviction that the team's ability is greater than the sum of its individual members. This is the main reason why the Kaizen activity should be carried out by improvement teams. So these principles tells us that it's not okay to not cooperate. And the last principle is to participate in the improvement work, since this is so important for the development of an organization. And we have to have in mindset that nothing is so good so it cannot be improved. We can always find better ways for an organization. So equally important are the leadership principles that guides the leaders of a lean organization. And the first principle is train. This includes training employees in lean and ways of working. Imagine to have the principle train in mind when you want people to behave differently. Compare that with the often used "how many times have I told them?" So the next principle that leaders should have is they should always follow up ways of working. And that could, for example, be that the people have followed the standards, or that they have used the 5 why method if deviation reappear, or if following standard and agreed things. The third principle is provide support to employees when necessary. Leaders should not give the employees solution, but rather provide support in order so they can find the solution by themselves. It will engage them. And the last principle is challenge. To set up new targets when for example, when we don't have so many deviation, we can challenge the organization to find even more waste by, for example, lowering the takt time, ask for other ways of working or something like that. So when we want to improve our operations, we need to change our behaviors, and the principles will guide the behaviors. So the aim of the employee principles and the leadership principles is to adapt to the behaviors in order to support the implementation of the lean principles. The employee principles and the leadership principles focus on how the organization shall behave, and the lean principles focus on how to think when we develop a flow or develop ways of working, for example. And the relation between the various sets of principles corresponds to the relation between our books. Our first book, Lean Turn Deviation to Success, focus on the lean principles and how they can be applied. The black book, Employee's Guide to Success, focuses on the employee's role in lean and the employee principles. And our orange book, Leadership Making Lean a Success, focus on the leadership behaviors and the leadership principles. And if you are interested in those books, they are available at Amazon. Thank you very much for your attention. Any questions?
Great. Thank you, Henric. And now we'll review any questions, as Henric mentioned. If you do have any questions, please submit them on the right side of your screen. Here's one. When creating flow within a work cell, is it more important to focus on resource utilization or material flows?
Can you take it again?
Sure. When creating flow within a work cell, is it more important to focus on resource utilization or material flows?
Hard to say, but I mean if a material flow is a problem, then of course it should have high priority, and I would say that when you have in order to get it reliable, I think you have to prioritize flow efficiency anyway. I don't know if that's a good answer, but
okay.
Yeah.
Okay. Thank you. And how stable must the process be in order to focus on flow, including quality, safety, bills of material, etc.?
If we should reach efficient flow, we can work with the buffer sizes. So if the processes are not stable, we can have a little bit bigger buffer sizes and still focus on the flow. If the processes are very unstable, I would say that they should not be in production. It should be in some kind of development phase, because you have to have some kind of level of stable production before you start to sell the products. I think it's in the core of stopping the process from Jidoka to put pressure on developing the process before you start to sell the product.
Okay, great. Well, thank you for all your questions. Unfortunately, we run out of time for additional questions. So any questions that we did not review, I'll send to Henric, and an email we'll send an email response back to you. So thank you for your participation and understanding. And thank you, Henric, for a very insightful presentation. Thank you, Jim, and your team for also joining us today. This brings our webinar to a close. Our next webinar will be on Thursday, September 24th, titled Pool Kanban Systems with Don Guild. Please visit AME.org under the AME Events and Training tab for more information and to register. And don't forget to fill out the short survey that will be in your inbox. Mark your calendars for the 2015 AME International Conference in Cincinnati, Ohio, from October 19th to the 23rd. Register online at www.ame.org/Cincinnati today. I hope to see you there. So thank you everyone for attending and have a productive day.